Hi class, this is Professor Waits and this video is the start of chapter 13. I will tell you that the introduction to classes can be a little bit of a struggle, so I want to make sure that you take your time on this and go through it. This week we'll be talking about the basics of classes and get you going on classes, and the next week we're going to talk a little bit more about some advanced pieces to classes. So, like I said, getting in and understanding classes is probably one of the more difficult things to do when learning to program. I find it to be even a little bit more difficult when you're talking about C++ than if you were taking some other language like Java or C#. And part of that is because languages like Java and C# are object oriented, they're class driven from the very beginning. And so that transition into utilizing classes seems to be a little bit more seamless. But I don't want you to get worried about that because we're going to go through this and I'm going to talk about some really neat ways to take a look at classes and understand classes. So let's strap in, let's get into it. And like I said, just take your time with this to get to understand it. The other thing too is you're going to find that we're probably going to have the videos of this presentation or this chapter split up a little bit more. You're going to have probably more shorter videos for this chapter. So that way you can go back and rewatch just the section you would like to rewatch. So with that, let's go ahead and talk about that first section, which is 13.1, the procedural and object-oriented programming. So now, the beginning of this class, we're going to talk a little bit more about theory per se than actually really diving into actually creating classes. We're going to talk a little bit about classes themselves, but we need to give a little bit of a backstory. So when it comes to development, we used to do things very procedural. And procedural focuses on the process and actions that occur in a program. The other thing about procedural is that code was definitely pretty much the beginning of the code. So the beginning of the code, someone would come in and say, okay, here's the start of the program. And here's the next line, and the next line, and the next line, and the next line. In fact, in much older programming languages, things like BASIC, we would actually go ahead and say, okay, line 10, and write out our function, or not function, but our line of code. 20, our line of code. 30, our line of code. And if we needed to insert something, like let's say we made a mistake and we forgot to set up a variable or do something to that variable, we would come in and we would say 15 and put that line of code. And we could keep doing this. We could then say 12 and as you can see, we would always kind of split the difference down the middle when we're inserting lines, in hopes that we would always have one, at least, one more space in between to add code. So that was very procedural. It definitely, I guess at the time it worked, and it's what we did. And then that moved on to some other languages, and at some point, we dropped maybe the numbering. We still had code. And by the way, a lot of times people will now call that kind of development where you just have one line after another, they'll call it spaghetti code. And part of that is because it's just this jumbled mess of code, right? That's everywhere. And as you can see, it's these bunch of these lines. And when you open that and you start looking at it, when you start looking at it, let me do that again so that way we can. and you're trying to understand where it is. And again, if you're debugging, you would have to, pretty much start at the very beginning and go line by line by line. And somewhere in this mess of code would be the spot that you're looking for exactly. So here's that's what I was looking for. And so it just kind of, at some point, people started saying, oh man, this is just spaghetti code. And it was obnoxious, and it was a pain in the butt to really get in there and find things and get used to it. So that was kind of the backstory of why we had procedural code. It was what we had at the time. It was the best thing we had at the time. And then what happened is someone came along and said, code doesn't really work this way. Code doesn't start from, or I should say, coding doesn't have to start from their very beginning and go straight down. What about these pieces where we, go over and do this, or where we go over and do that? And we had the ability to do that. We had, we could say go to, and we could then go to a line of code. So we started setting up for this idea that code can jump around quite a bit. And then on top of that, we started realizing in programming that, for the most part, a lot of our programming is actually surrounds data and what we want to do with that data, and how to take in data, how to manipulate that data, how to then save that data, and so forth and so on. And what started emerging was this idea of object-oriented languages. So one thing to understand about object-oriented programming is, and actually we're going to talk about a couple of things that you really need to kind of, at first you're going to memorize it, and then it's going to start to just be part of the functioning of how you utilize objects. And so become a little less memorization, more of a experience of how you develop with classes. So objects are instances of ADTs. Do you remember what ADTs are? Advanced data types. And so what we found is we started developing these types, these data types that represented more of a functional piece rather than just these one-off pieces. So what does that mean? Well, part of what that means is that pieces or development comes in pieces. You don't develop, let's say, a web form. So here's a web form, right? And even your web form is going to have, let's say, a name. It's going to have, let's say, maybe a phone number, an address. Well, what is that? Well, that is a representation of a person. Okay, great. That works. Now down the road, let's say we want that person to register for a class. So somewhere else in the system, an administrator comes in, and here's another form. What's the class name? When does it start? What's the subject? When does it end? What's the description? And then all of a sudden we have a class. And by the way, when I say class here, I don't mean what we've been talking about in coding. I mean we actually have a class like C++ or a class like history. We have a listing of an educational class, right? Not to get confused with programmatical class. So we started to realize, okay, so a lot of what we do comes as these objects. We live in a object type of world. Your car is an object. Um, the water bottle that you drink from is an object. And objects have properties. All right. I don't know what the hell that was about. Let's try that again. It has properties. And then we always want to be able to do stuff on those properties, right? Why have something that has a bunch of properties and not be able to do anything with it? Well, we actually do have that, right? So we know that a struct is a bunch of properties. And that's great. And that works for the structs. But we wanted to be able to have something that can also manipulate those properties. So we started putting functions into our objects, and that's where we start talking about classes. All right. So one of the things about that procedural programming we talked about, that spaghetti programming, is in the data structures, if the data structures change, many functions must also be changed. And that's what was really, I mean, just the sheer magnitude. If you had a really big program, I remember one of the first programs that I wrote and actually sold was a program that helped companies, rental companies, manage their rental properties. And it was procedural code, and it was really long. I think when I had to have it evaluated, I printed it out. A pretty standard printout, probably 10-point font, so forth and so on. And I think it came out to something short of like 3,000 pages of code, probably close to a couple million lines of code. And um, so the problem with that is, if there's a bug in that, you're trying to dive into that and figure that out. And so, and then the other thing too is if I needed to make change in one part of the code, oftentimes that meant there are other places in the code that would need that change too. So now I'm going through and I'm making this change multiple places. Hopefully I didn't miss any, and so forth and so on. So, when your data structures change, so let's say, you first start out with a name and you said, you know what, we're just going to have first name and last name. And then down the road, you realize there's some value to adding the middle name. Now you go back and add the middle name, but now you're going to have to go through all of this code and figure out where you've used that name and make changes to your code in all these different places to manage that. And then programs that are based on complex functional hierarchies are difficult to understand and maintain. And this is the one big piece that really was the headache about procedural code. It's difficult to modify and extend. In fact, we would kind of go through and develop all these weird ways of making sure that our code was somewhat extendable. And again, we were just trying to fit a square peg in a round hole because procedural code was designed for that. And obviously, it was easy to break. Worst off is when it did break, finding the issue. Oh, did it again. Finding the problem was painstaking. All right. So, ta-da! Object-oriented programming terminology. Well, that's because object-oriented programming came along and did solve a lot of these problems. So we've already talked about the fact that we've worked on structs, and they're very similar to a class. It allows the bundling of related variables, like a struct, But the variables and functions in the class can have different properties than a struct. Now, class versus object. An object is an instance of a class, in the same way that a variable can be an instance of a struct. Let's try that again. A class and an object. A class, like a struct, has the ability to have variables and functions in it, very similar to a struct. A struct does not allow functions, but a class does. And then you have an object, which is an instance of a class. It's the creation of that class. It's the realization of that class. And just like we have a variable, and that makes an instance of a struct, an object is an instance of that class. So let's take a moment and take a look at this slide. We've got this concept of blueprint. Another concept that you'll hear oftentimes is that a class is a template. And that's because a class itself isn't actually anything that is tangible. It's just a blueprint. It's just a template. It's just a description. It is just a description for an object. So just like in a blueprint, we describe everything we need to know about a house. Sizes and maybe even materials, and you name it, it's in that blueprint. But that blueprint is just a series of papers. It's not an actual house. If you want a house, if you want to instantiate a house, then what you're going to have to do is you're going to build an instance of the house described by the blueprint. And the interesting thing to understand about that is when you do that, each time you create an instance of that template or that class, it's going to be exactly the same looking, but not the same object. So let me try that again too. Make sure you understand that. If you instantiate, by the way, I keep using the word instantiate because that is a common word in object-oriented programming. When you make an actual object from a class, you're instantiating it. So when you instantiate an object from that blueprint or that class, you get an exact replica of the blueprint. So the objects themselves at beginning look the same, and the structure is the same, and everything about that object will be the same. Now, where it gets different is obviously the data that you start storing in that class, or in that object. Because remember, you're not storing data in a class because a class is just the template. It's just the blueprint. It's just how to describe what the object should look like when you instantiate it. The object itself starts to become its own object as you start loading data into it, as you start using it to and manipulating the data inside of it. And that's why, for example, let's take the concept of a wheel, a car wheel. Well, we all know what a car wheel is. In fact, if I said to you right now, picture in your head a car wheel, you all would picture a car wheel, probably a car wheel that's similar to maybe something that's either on your car or a friend's car, right? You're going to, in your brain, create an object that is of type car wheel. Now, some of you are thinking of a car wheel. Some are thinking big truck tire. Some people are probably thinking, like me, that four-wheeling, oh goodness, that, come on, okay, that four-wheeling tire just got the big knobbies on it. And they all are a car wheel. They have a size. Let's say that they have a speed rating. Materials. And as we start to fill in this object with these pieces of data is how we get a car wheel or a truck wheel or a four-wheel drive tire, an all-terrain tire. And so that's the same thing is at first, when you first instantiate an object, it's going to resemble all the other objects from that template. That's the point of having a template. It's as we start loading data, they start to take on their own representation. So some object-oriented programming terminology. Attributes. Attributes are the members of a class. You will oftentimes, call them variables, right? It's those pieces that are in the class. So when we start looking at a class, you're going to have, maybe ints. Maybe you even have some kind of struct. So we're going to call it my struct. Maybe you have another class as a variable. But these are all attributes. And then we have methods. Now, in my professional experience, I've never heard someone call them behaviors, but it makes sense because, again, like I said, a class has attributes and then methods that are meant to change the attributes within the class, which means that methods are nothing more than behaviors. It is going to act on variables and do certain things to those variables. And so that's why it makes sense to sometimes call them behaviors. A little bit more on objects, and then I think we're done with this video. And so let's go ahead. So data hiding is the restricting access to certain members of an object. This is one of the most important pieces to programming and oftentimes one of the most overlooked pieces of object-oriented programming, any kind of programming. The more you allow your program to be freely changed, the more bugs you're going to have. That's just something to kind of get used to. If something should only be updated, let's say when the application first starts or the first time it gets assigned, and it should never be changed again, you should make sure you're developing your code in a manner that stops that. Data hiding is restricting access to certain members of an object, and part of that is to stop external changing of variables. So one of the first things that you're going to learn in that data hiding is public interface. That's members of an object that are available outside of this object. Anyone outside of this object can see those variables and those members. This allows the object to provide access to some data and functions without sharing its internal details and design, and provides some protection from data corruption. So what you're going to start seeing is in our classes, we're going to be able to say that something is public or something is private. And this is that data hiding. This is what allows us to say, you know what, in this object or this class, we're going to make some of the items in the class only known to itself, and we're going to call it private. And the reason why we're going to do that is because the functioning of this object from an external point of view doesn't matter. We don't need the external person or the external user. And when I say external user, I'm talking about even the class itself or the code itself, right? We don't need other bits of code to even see these pieces, because while it is relevant and needed inside the class itself, everyone else doesn't need to know about it. And we definitely don't want them changing it, because it's going to cause problems if they can change it. And that's kind of where I said that this is oftentimes one of the most overlooked pieces, is because what happens is developers get a little bit on the lazy side and they just make everything public. And the problem is then they get really upset when someone comes along and remember, when you're working in teams, you have other people that are going to come in and work on code, oftentimes very close to what you're working on and in parallel to what you're working on, or even worse, down the road, when you've written this class and way down the road, months down the road, years down the road, you come back and you make a modification to your code or add to your code, and you forget yourself that this piece of code or this member variable wasn't supposed to be changed, and you do, and now you've got bugs all over the place. Well, again, if you mark those items private and you keep them internal to the object, you don't have to worry about external pieces or code changing this really important and relevant item inside the object. So again, remember, data hiding. Make sure you set access to your items inside your class to a certain level. Now, with that being said, I believe it's a little bit down in the presentation where we actually start showing some of that, but I just want you to kind of keep in mind, what that is, and that's that data hiding. Right. So that's where we're going to stop on this video. In the next video, we're going to actually jump in and really start to take a look at what a class is and how to develop a class and all the fun pieces that come along with classes. So I hope to see you soon. Again, if you need to go back, I know that this video was quite a bit of more kind of theory-based, but it is important to know all the things that we just talked about. It's going to create a good foundation on the classes that we're about to jump into. So until then, I will see you, and we'll talk again. Thanks.